Hello, welcome to our investor's pitch for an idea designed to combat invasive species and the issues they pose.
Hello, my name is Isaiah Wang.
I'm Lauren Spehlmann.
My name is Victoria Spencer.
And I'm Clara McAllister. We're all juniors from Thomas Jefferson High School for Science and Technology.
And now onto our product. Our product is called the Targeted Invasive Species Eliminator, also known as TISE for short. It will be a restoration-tailored AUV, meaning it restores the natural balance of ecosystems by eliminating invasive species. The purpose of our product is to combat the negative effects of invasive species. Invasive species deplete local marine wildlife by exhausting resources and outcompeting native wildlife. They disrupt natural communities and ecosystems, so by eliminating them, or even just minimizing their populations, we would be able to help replenish the natural populations and help to restore the ecosystem back to its status quo. Invasive species also negatively affect the economy. According to the National Invasive Species Information Center, a 2005 approximated a loss of $120 billion per year in the United States alone due to invasive species. Marine invasive species decrease the local marine wildlife populations, meaning fishermen have lower catch yields and thereby less profits. And because of this, the local government has less revenue and consumers have fewer product choices, which harms the economy.
Now, as for what our product is exactly and how it works, as stated before, our product is an AUV, also known as an autonomous underwater vehicle, that is tailored towards targeting and hunting specific invasive marine species, such as lionfish and crown of thorns starfish. To do this, there are four main components. First of all is a video camera that is live streaming to the Arduino board inside the AUV that allows the program in the Arduino to be able to see its surroundings and identify objects, obstacles, and targets. Then there are two main programs within the Arduino. One is an AI that allows the AUV to move around its surrounding waters while avoiding obstacles and searching for a target. Once a target is found, it will switch into the hunting algorithm, which will bring the AUV closer and closer to the target until it's within hunting distance, in which case the spear or syringe located at the front of the AUV will launch out and pierce the animal either through the head or through the body. And if necessary, and this is mostly for marine invertebrates like starfish, it will inject a natural toxin like vinegar or some salts in order to actually kill the animal. And lastly, there is a GPS in the device that allows the user to know where it is at all times, and also allows the device to know which way to head back to its port. As for scientific merits of our product, first of all, the mechanics. We use propellers and rudders to move and direct the AUV, both of which are very common methods of moving around in the water, nothing revolutionary and very easily implementable into our product. The second piece of scientific merit would be existing AUVs, which many researchers use these days and are very accurate in avoiding obstacles and in collecting information around them. So there's nothing to say that our AUV would not be able to work. The next component are the hunting methods that we have stated. The two hunting methods would either be piercing the fish through the head, which is the most painless and most efficient way of killing them, and injecting invertebrates like starfish with natural toxins such as vinegar or salt. Both of these are governmentally approved and don't violate any animal protection laws. Lastly is the actual hunting algorithm, process, which though is new, there are no others like ours. There's nothing about modern coding that says we wouldn't be able to do this. It would take many trials, however, it is 100% plausible to create an AI that targets and kills invasive species. And lastly, here you can see a quick sketch of what the product would look like. You can see the streamlined body, a camera lens hole at the top or the front for the algorithm to see, a spear or syringe launcher near the front bottom, propellers on both sides to create an even movement, and rudders on the back to control the direction.
And now onto our business analysis.
There are no current devices or products that are similar to our product and have a patent. There are a few other products that are currently being developed, however, they don't have patents and aren't as good as our proposed device. Our product has more versatility and autonomy than others, which also makes it better. Its autonomy makes it more efficient, and its versatile killing methods helps it kill more types of invasive species, and it's also more efficient.
In order to bring our product to the market, it is necessary for us to license it to production companies. This would allow our device to have a significant impact on the environment through large-scale production, since it wouldn't be possible for us to produce enough AUVs on our own. Our target sales would be directed towards the government, since this is what manages natural conservation and restoration. We also intend on seeking government contracts. A final method of bringing our product to market is in the form of commercial industries. Some specific marine invasive species, such as the lionfish, have potential for profit in the fishing industry, and therefore we could market our product to private fishing companies.
Given the size and parts needed for our AUV, its maximum cost would be around $600 per AUV. Assuming we sell around $10,000 per year, we would need around $6 million per year. We would also need to take into account the cost of shipping. Given the AUV's weight, it would take about $70,000 to ship our product. However, these are all maximum costs that it would take, so a more realistic budget would be around $4.75 million. The proposed budget to cover our flight, stay for 3 days, and food for 3 days to go to the summit would be around $1,860, which will be about $370 per person for our 4-member team and coach.
In the initial earlier stages of production, we intend on small-scale fundraising through our school and the bioengineering club we're all members of. We would ask for donations from our friends, family, and our school throughout the entire process. Later, we intend on gaining government funding, since the government would definitely have interest in the environmental prospects generated by our product. A final method of funding would be through private investors and angel investors who could provide a significant amount of money.
Thank you for taking the time to listen and consider our product. We hope you're interested in what we presented, and we're excited to hear your feedback.